wiring between a generator and a transfer switch is classified as a feeder, not a service. To understand this distinction, it's important to define what constitutes a service. A service encompasses the conductors that run between a service drop or lateral and the building's service equipment. In simpler terms, it's the direct connection from the utility company's power source to the building's main electrical system. Because the generator is not directly connected to the service entrance, the wiring from the generator to the transfer switch does not meet the definition of a service. Instead, it functions as a feeder, supplying power to the building's electrical system through the transfer switch. This distinction is important for determining the correct wiring and grounding requirements. Now, let's discuss grounding. The grounding conductor for the feeder between the generator and the transfer switch must be sized according to NEC Table 250.66. This table provides guidelines for size and grounding electrode conductors based on the size of the service entrance conductors. It's important to note that NEC Table 250.122, which applies to equipment grounding conductors, is not applicable in this case. The grounding conductor size is determined by the overcurrent protection device protecting the feeder. To determine the appropriate grounding conductor size, you will need to identify the rating of the overcurrent protection device, such as a circuit breaker or fuse that protects the feeder conductors. Once you have this information, you can refer to NEC Table 250.66 to find the corresponding grounding conductor size. For example, if the overcurrent protection device is rated at 200 amps, NEC Table 250.66 might specify a minimum grounding electrode conductor size of number 6 copper. It is crucial to consult the most recent edition of the NEC and local amendments to ensure compliance with the applicable regulations. The NEC provides detailed requirements for grounding and bonding to ensure electrical safety. Proper grounding helps to minimize the risk of electrical shock, equipment damage, and fire hazards. In addition to sizing the grounding conductor correctly, it is also important to ensure that it is properly installed and connected. The grounding conductor must be securely connected to a suitable grounding electrode, such as a ground rod, ground plate, or metal water pipe. The connection must be made using approved methods and materials. Furthermore, it is essential to maintain the integrity of the grounding system over time. Regularly inspect the grounding connections for corrosion or damage, and repair or replace any defective components promptly. A properly installed and maintained grounding system is critical for protecting people and property from electrical hazards. In summary, the wiring between a generator and a transfer switch is considered the feeder, and the grounding conductor for this feeder must be sized according to NEC Table 250.66, based on the rating of the overcurrent protection device. Always consult the latest edition of the NEC and local amendments for specific requirements, and ensure that all work is performed by qualified personnel. It is important to understand the difference between a feeder and a service in electrical systems. A service, as mentioned, is the connection between the utility company's supply and the building's main disconnect. This includes the service drop or lateral and the service entrance conductors. This service equipment includes the main breaker or fuse disconnect, meters, and related components. A feeder, on the other hand, extends from the service equipment or a separately derived source, like a generator, to a subpanel or other distribution point. Feeders carry power to various parts of the building or electrical system. The key distinction lies in the origin of the power. A service originates from the utility company, while a feeder originates from the service equipment or a generator. In the case of a generator serving as a backup power source, the wiring from the generator to the transfer switch is a feeder because it's distributing power from a source that's not the utility company's service. Now, diving deeper into grounding requirements, the NEC specifies different rules for grounding services and feeders. For services, NEC Table 250.66 is used to determine the size of the grounding electrode conductor, which connects the service equipment to the grounding electrode system. For feeders, NEC Table 250.122 is typically used to determine the size of the equipment grounding conductor, which runs with the feeder conductors to provide a low impedance path for fault current back to the source. However, In the case of a generator feeder, NEC Table 250.66 is used for sizing the grounding conductor. This is because the generator is considered a separately derived system. A separately derived system is an electrical power source, such as a generator, that is not electrically connected to the building's service. Because the generator is a separately derived system, the grounding requirements are slightly different than those for a typical feeder. The grounding conductor must be sized according to NEC Table 250.66, based on the size of the generator's output conductors. It's essential to ensure that the grounding conductor is properly connected to the generator's frame and to the building's grounding electrode system. This will help to ensure that fault current can safely return to the generator, minimizing the risk of electrical shock and equipment damage. Let's consider a more detailed example. Suppose you have a generator rated at 100 kilowatts, 480 volts, 3-phase. To determine the appropriate grounding conductor size, you would first need to calculate the generator's output current. Using the formula current equals power divided by the square root of 3 times voltage, you would find that the generator's output current is approximately 120 amps. Next, you would refer to NEC Table 250.66 to find the corresponding grounding conductor size. For a 120 amp generator, NEC Table 250.66 might specify a minimum grounding electrode conductor size of number 6 copper. It's important to note that this is just an example, and the actual grounding conductor size may vary depending on the specific installation and local codes. Always consult the latest edition of the NEC and local amendments to ensure compliance with the applicable regulations. In addition to the grounding conductor, it's also important to properly bond the generator's frame to the building's grounding electrode system. Bonding is the process of connecting metallic parts of the electrical system together to create a low impedance path for fault current. This helps to ensure the fault current can safely return to the source, minimizing the risk of electrical shock and equipment damage. The generator's frame should be bonded to the building's grounding electrode system using a bonding jumper. The bonding jumper should be sized according to NEC Table 250.66 based on the size of the generator's output conductors. It's also important to ensure that all metallic conduits and enclosures are properly bonded to the grounding system. This will help to prevent voltage differences between metallic parts, which could create a shock hazard. When installing a generator and transfer switch, it's crucial to follow all applicable electrical codes and standards. This includes the NEC, as well as any local amendments or regulations. It's also important to use qualified and licensed electricians to perform the installation. Qualified electricians have the knowledge and experience necessary to ensure that the installation is safe and compliant with all applicable codes. In conclusion, the wiring between a generator and a transfer switch is considered a feeder, and the grounding conductor for this feeder must be sized according to NEC Table 250.66 based on the rating of the overcurrent protection device. Always consult the latest edition of the NEC and local amendments for specific requirements, and ensure that all work is performed by qualified personnel. By following these guidelines, you can help to ensure that your generator system is safe, reliable, and compliant with all applicable codes and standards. Also, it is critical to maintain proper documentation of the electrical system, including the generator and transfer switch. This documentation should include wiring diagrams, equipment specifications, and grounding details. This documentation can be helpful for troubleshooting and maintenance, and it can also be required for inspections and insurance purposes. Finally, remember that electrical work can be dangerous, and it is always best to leave it to the professionals. If you are not comfortable working with electricity, hire a qualified electrician to perform the installation and maintenance of your generator system. Electricity is not something to take lightly. Understanding the difference between service and feeder conductors helps ensure a safe and code-compliant electrical system. Service conductors bring power from the utility to the building, while feeder conductors distribute power from the service equipment to other parts of the building or from a separately derived source like a generator. The National Electrical Code Article 100 defines both terms precisely. Grounding requirements for generators are crucial for safety. When a generator is used as a backup power source, the grounding conductor size is determined by NEC Table 250.66. This is because the generator is considered a separately derived system. The size of the grounding conductor depends on the size of the generator's output conductors and the overcurrent protection device. Bonding the generator frame to the building's grounding electrode system is also essential. This ensures a low impedance path for fault current, minimizing the risk of electrical shock. The bonding jumper should be sized according to NEC Table 250.66. All metallic conduits and enclosures must also be properly bonded to the grounding system. Regular inspection and maintenance of the grounding system are necessary to ensure its integrity. Check for corrosion or damage to connections and replace any defective components promptly. Proper grounding protects people and property from electrical hazards. Consider a scenario where a 200 kilowatt generator is installed. The first step is to calculate the generator's output current. If the generator is 480 volts, three-phase, the output current is approximately 240 amps. Next, refer to NEC Table 250.66 to determine the minimum size of the grounding electrode conductor. For a 240 amp generator, the table might specify a number 4 copper conductor. The bonding jumper connecting the generator frame to the building's grounding electrode system should also be at least a number 4 copper conductor. Remember, these are examples, and the actual sizes may vary based on specific installation requirements and local codes. Always consult the latest edition of the NEC and local amendments. In addition to conductor sizing, proper installation techniques are critical. Ensure that all connections are tight and secure. Use approved connectors and fittings. Protect conductors from physical damage. Follow manufacturer's instructions for equipment installation and maintenance. Document the electrical system thoroughly. Keep wiring diagrams, equipment specifications, and grounding details readily available. This documentation aids in troubleshooting and maintenance. Regular maintenance of the generator is also important. Follow the manufacturer's recommendations for oil changes, filter replacements, and other maintenance tasks. Test the generator regularly to ensure it operates properly during a power outage. Safety is paramount when working with electrical systems. Always de-energize circuits before working on them. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. If you are not qualified to perform electrical work, hire a licensed electrician. Electrical work can be dangerous, and it's always best to leave it to the professionals. Stay updated on the latest electrical codes and standards. The NEC is updated every 3 years, and it's important to be aware of any changes. Attend continuing education courses to enhance your knowledge and skills. By following these guidelines, you can help ensure a safe, reliable, and code-compliant generator system. And always prioritize safety when working with electrical systems.